Hello Algebra 2 students, these are your notes on solving radical equations. It's the root here that makes this equation a radical equation. So solving radical equations that are simple, just a few steps. If you have a minus 5 and you're trying to isolate the x, you need to add 5 to get rid of that. And you have the cube root of x equals 5. Now the way to get rid of a cube root is to cube both sides. So cube root and cube are inverse operations, they undo each other. So on the left side, the cube root and cube will cancel out, leaving you with just x. And on the right side, you need to actually do 5 to the third power, which is 5 times 5 times 5, and you should get 125. Alright, in problem 2, first we have to get the root all by itself, so we need to get rid of a plus 6. And I have 2 times the fifth root of x equals 4. Now I need to get rid of the 2 times, so I divide. And I have fifth root of x equals 2. And to get rid of a fifth root, you need to raise both sides to the fifth power. So on the left, the fifth power and the fifth root cancel out. And I have x equals 2 to the fifth, which is 2 times 2 times 2 times 2 times 2. So let's see, that gives me 8, 16, 32. Alright, if your problem has exponents instead of having a root, there's actually 2 different ways you could handle this. One is to just think of it as a root. Remember that this fraction is power over root. So this is the same as the square root. You could put a 2 in here if you want, but usually you don't see that 2 written for square root. And then to the third power equals 8. Okay, so you could get rid of the square root and the cube in either order. It's your choice. Let's say we got rid of the square root first. So if we got rid of the square root first, you would square it. And so now I have x cubed equals 64. And then to get rid of the cube, you want to cube root it. Now there is a cube root button on your calculator. If you press the math button and you find the cube root, you could do cube root of 64. But in your head you're thinking some number times itself gives you 64. A lot of people want to say 8, but 8 is the square root of 64. This answer is 4, because 4 times 4 times 4 gives you 64. Alright, if you like that method, you can ignore this other method, but this might be the way your teacher taught you. If you have x to the 3 halves equals 8, another thing you can do is you can raise both sides to the reciprocal of 3 halves. So that would be to the 2/3. And the reason this works is because if you have power to a power, you multiply your exponents, and 3 times 2 is 6, and 2 times 3 is 6, so you get x to the 6 over 6, which is just 1, x to the 1. So if you raise it to the reciprocal, you have x to the 1 equals, and remember again, this is power over root, so you could do cube root of 8 squared. You can also put all of this in the calculator to get your answer. So you had 8 to the 2/3. But here, cube root of 8 is 2, because 2 times 2 times 2 is 8. So you have 2 squared, which is, again, 4. So it doesn't matter if you want to use this method or this method. It's your choice. In the next problem, before we can do either method, we have to get rid of the 3. So divide by 3, and you have x to the 2/5 is equal to 4. So that means square root of x. Nope, that means fifth root of x squared equals 4. So you can get rid of the square first by square rooting both sides. So if I square root and square root, that square root will cancel out my square. So I have fifth root of x equals 2. And then you're going to do fifth power. So let's see, fifth root of x equals 2. And then you're going to do fifth power. So the fifth power cancels out the fifth root, and x is equal to 2 to the fifth. 2 times 2 times 2 times 2 times 2. I think we've done this already. This is still 32. Alright, and then if you did that with the other method, you would raise both sides to the 5/2 power to undo this, and you would still have 4 to the 5/2 equals 32. Alright, here we are going to solve some equations again, so we need to get the radical by itself first, so divide by 2. Cube root 3x minus 5 is equal to 2. Now you're ready to get rid of the cube root, so you cube both sides. And this cancels. So I have 3x minus 5 equals 2 to the third. 2 times 2 times 2 is 8. Alright, add 5 to both sides. 3x equals 13. And now divide by 3. So x is going to be the fraction 13 over 3. Alright, this time the radical is being divided by 3, so you want to do the inverse operation. You want to multiply by 3, and those cancel. So I have square root 2x plus 1 equals 12. To get rid of the square root, you're going to square both sides, and you get 2x plus 1 equals 12 squared. 12 times 12 is 144. Okay, let's see if I have space over here. So I have 12x plus 1 equals 144, and you need to get the x by itself, so subtract the 1. Oh, I said 12x, that's just 2x. 2x equals 143, and now divide by 2. So x is going to be 71.5. Alright, this next one is tricky because this radical is already by itself, so I'm going to square both sides. But this side has two terms, so if I want to square this side, I need to put parentheses before I square it. Now the left is easy because the square root and the square will cancel, so I get 8x plus 1 equals. When you square x plus 2, you cannot square each term. You have to actually write x plus 2 times x plus 2 to figure out what this is going to give you. So then when you multiply it, x times x is x squared. X times 2 is 2x. 2 times x is another 2x. And 2 times 2 is 4. So x plus, or 8x plus 1 equals this. These two combine to give you 4x, so I have x squared plus 4x plus 4. Now this equation is quadratic, I can tell because of the x squared here. So what I'm going to do is try to get one side to be 0. So if I subtract 8x, I can move my x's to the right side. And if I subtract 1, I can move my constants to the right side. So now I have one side that equals 0, and the other is x squared. 4 minus 8 is negative 4x, and then plus 3. So to solve a quadratic equation, I could factor it, or I could use quadratic formula. This one seems to be an easy one to factor. I need two numbers that multiply to 3 and add to -4. So I think that's -3 and -1. So I can write 0 equals x minus 3 times x minus 1. And then if you set your factors equal to 0, you get x equals 3 and x equals 1. Now we should check and make sure none of these solutions are extraneous. So I'm going to plug them back in. So if I do square root of 8 times 3 plus 1, does that equal, if I plug in 3 on the other side as well, 3 plus 2. So I'm checking my answer of 3. 24 plus 1 is 25, so I have square root of 25 equals 5. Well, this is true. Let's check the other answer, 1. Square root of 8 times 1 plus 1 equals 1 plus 2. So this is going to be square root of 9 equals 3, and that also works. So I have two solutions. They're right here. Alright, next page. Okay, I have two radicals. So the directions are get one radical on each side. So I can add this one to move it to the other side, the side that has nothing. So I'm adding it to the 0. So it's a cube root 2x plus 4. So now that I've added it to both sides, it's gone here, and I have it on the right side. So cube root x minus 1 equals cube root 2x plus 4. And now I can cube both sides, and I have a pretty easy equation. Cube cancels out cube root on both sides, so I have x minus 1 equals 2x plus 4. So I want to get x's to the same side, so I'm going to subtract x from both sides, and that will cancel. So I have -1 on the left. 2x minus 1x is x plus 4. And now to get the x by itself, I subtract the 4. -5 equals x. Alright, and in number 9, I have square roots on both sides. I have a 3, but it wouldn't make any sense to divide by the 3 because that would just move it over here. So let's go ahead and square both sides. I square on this side, and I need to square both the 3 and the square root on this side. So my squaring and my square root cancel, and I get 3x minus 6. I have to square the 3, so I get 9. And then here, the square and the square root cancel, so it's just 9 times 2x. So I get 3x minus 6 equals 18x. And now you need to get rid of your x's on one side, so I'm going to subtract 3x from both sides. And I get -6 equals 15x, and then divide by 15. So -6 over 15, that actually simplifies if you divide the numerator and denominator by 3 to -2/5. Another way you can get that answer is divide on your calculator, -6 divided by 15, and then press math fraction. Alright, so remember back on the last page we had checked our solutions to make sure they weren't extraneous. Here are some problems where extraneous solutions may just come up. Let's see what happens. In number 10, we have to isolate the radical, so I'm going to subtract 1. And I get square root 3x plus 1 equals -2. Now I want to square both sides, so I square this and I square this. and I get 3x plus 1 equals 4, because negative 2 times negative 2 is 4. Subtract 1, I get 3x equals 3, and divide by 3. So I get a solution of x equals 1. Now I'm going to check it back in the original. So I put 1 where the x is. I have square root 3 times 1 plus 1. And then another plus 1 outside the square root equals negative 1. So 3 times 1 plus 1 is 4, so I get square root 4 plus 1 equals negative 1. 2 plus 1 equals negative 1. This is not true. So this answer does not actually work, even though you did all your steps right. It's an extraneous solution. So there's actually no solution to this problem. All right, let's try 11. In 11, we're going to square both sides. So this goes away, and I get x plus 7. Let's see, when I square a negative, that turns positive, so I don't need to worry about the negative. So I have x plus 1 times x plus 1. And then I get x squared plus 1x plus 1x plus 1 equals x plus 7. Combine like terms, x squared plus 2x plus 1 equals x plus 7. And now when you solve a quadratic, you need to make one side 0. So subtract x and subtract 7 so that your right side will be 0. So I'm going to bring it over here now. I have x squared. 2x minus x is x. 1 minus 7 is negative 6. So to factor this, let's see, my b value is 1. So I need two numbers that multiply to negative 6 and add to 1. So those numbers would be positive 3 and negative 2. X plus 3 times x minus 2 equals 0. Set your factors equal to 0. I get x equals negative 3 and x equals positive 2. Now we need to check both of these solutions. So I'm going to check them here. First one, negative 3 plus 1 equals square root 3, negative 3. Let's see, this answer is negative 3. Plus 7. Alright, so negative 3 plus 1 is negative 2, and then there's a negative outside of that, so that's positive 2. And then over here, square root of 4 is also 2. So this answer works. Alright, let's check this one. Negative 2 plus 1 equals square root 2 plus 7. So this gives me negative 3 equals square root of 9. Negative 3 equals positive 3. So this one doesn't work. So this answer is extraneous. And this is our answer. So we have just one solution to this problem. Okay, and this is the end of this page of notes.